Well, hey, folks, for those who have joined us, thank you very much for being here. It looks like we're about ready to get started. I'm going to make an announcement again. For those who have registered for the class, please go to spring.academy and register for a free account. For those that have come in and have not registered, we ask you to audit the course. We do not have enough labs for those people that have not registered, but feel free to ask your neighbor if you can look over their shoulder and look at what they're doing. And if they say, they may not feel comfortable, come see me, and then I'll ask for a volunteer that you can maybe pair up with and watch, and you can share the experience together. Okay? And we're going to continue miking up real quick.
Make it louder.
All right. So.
We've got something.
Okay. All right. So, folks, real quick, I'm going to go ahead and let's introduce our speakers today. Corneil, click a button and let's begin the introduction. Chris?
Chris Bono, software engineer on the Spring team. I work on Spring Cloud Data Flow, Spring Cloud Stream applications, and Spring Pulsar.
Sweet. All right.
Why so demure? My name is Corneil de Plessis. I'm from South Africa. Joined the Spring team last year in March, but I've been a Spring user since 2004, and my first application went into production in 2005, and it was the core for a mobile and telephone banking system, and it was extended to support the internet banking system. So that was basically the POC, and it's still at the heart of their Spring Boot app that runs their internet banking. And it does support about 2 million customers. So I'm pretty proud of that one. I've been doing Java since, the early days, 95, I started playing with it. In 98, I went into production with the Java app the first time. And I am co-organizer of the Johannesburg, or Josie Jug, as we call it. And I've been doing that for about 12 years. But this is my first international stage. So thank you for joining us. And
well, hello, folks. My name is Glenn Renfro. I'm on the developers at VMware as well. I work on Spring Cloud Task, Spring Cloud Data Flow. When my mood says it's okay, I actually work on Spring Batch. When I'm not on doing all that, and break glass in case of emergency, Oleg says I can work on Spring Cloud Stream. When I'm not doing that, I'm on the board of directors of Atlanta Java Users Group, as well as on the board of directors for Dev Nexus. Right now, it's the largest Java conference. I think we've declared it in the world right now. And then finally, I just minted as a Java champion as of yesterday. So, folks, welcome. Come on in. And Corneil, real quick, I'm going to step off the stage, but why Spring Cloud Data Flow?
That's why we're here today. So if you ask the question, why Spring Cloud Data Flow? So as your business processes data, you'll need to build dedicated applications and deploy and manage and monitor these applications. And you could probably do it without Spring Cloud Data Flow. But Data Flow offers a lot. So when we ask the question why data flow and we talk about data processing, well, what's data processing? So we're not just moving data around, we're probably changing it in some way. And we have to consider if we have large amounts of data that needs to be dealt with regularly, or do we have continuous events? Thanks. Do we have frequent events that we need to process immediately? Because these are very different things. So how does data flow help? So data flow is an application that can orchestrate the deployment and the management, the monitoring of applications that process data in your business. So if we think back, there's some distinctions. So Getting an echo here. Can you turn this one off? Oh, okay. We've identified two types of data, and we're going to build two types of applications. The one would be an application that we want to be able to deal with events immediately. And we have applications that we want to start, do work, and then. So if the first one stops running, that's not a good thing. If the second one stops running, that's fine. So the first one is a long-running task, the second one is short-running. Or there are people that struggle to get their batch jobs done in a day, but we can help them deal with that. So let's dive in and talk about these event-driven stream applications. So we talk about, in that world, we talk about sources, processors, and sink. So source means that it's a source of data that's now coming onto the stream. So it can be something that's dedicated to pull something from a data source at a frequency, or respond to an external device, or whatever. But remember, it represents a source of data where it starts, and its responsibility is to put it on the stream. The processor is the one that is transforming or processing data. So it's doing some work. And it could be converting it from one format to another. It could be enriching it. It could be deciding we don't need this data. And there's a whole list of things we can do, and we're going to discuss more of that later. We can have a sink. So sink is the end of the stream. So everything of the stream goes into the sink, and the sink is responsible for either putting it in a data store or sending it onto a different kind of system. But that's typically how you define a stream: source, processor, sink. So if you want to be formal, you have at least one source and one sink. And 0 to n processors. So let's look at an example. So let's say there's an IoT device that can only produce HTTP requests because somebody who developed this didn't know about AMQP or anything like that. They can just make a HTTP request. So you can have an HTTP source that receives these events and puts them on the stream. Then you can transform or enrich this, and you can have a data store sink that now takes this data and puts it in a database. But you could, without disturbing that operation, tap off the data and do something else. Now that's powerful, because if you have a business that has something that's running and all of a sudden you need to produce this brand new kind of compliance report, what do? You don't want to disturb that. But if you have a streaming solution, you can tap that stream, and now you have an event source that you can deal with in different ways. You can push that into a whole other stream. And for the sake of your sanity, I would define that second stream as a separate stream so that you can deal with that and handle it. You can even take those events and let them trigger tasks. So the notion of a tap allows you to extend the stream in powerful ways. Now, we use the term tap, but in reality, that tap is a destination that has to serve multiple receivers. How do we do that? Well, we use a topic. In Kafka or in RabbitMQ, we use an exchange. If you're in the old JMS world, it's a topic. We do not have a JMS stream minder, so you'll have to find a different way to enter that world. And you'll probably do that via dedicated apps to bridge the gap. So these streams could be many and do many different things, some connected, some not connected to each other. And data flow allows you to manage and visualize all of these streams. So now let's look at short-lived or ephemeral tasks. So there is an abstraction called Spring Cloud Task. What does that mean? That means it's an application that we know is going to run and do something and then stop. But we need to know that this happened. So it has the responsibility of updating the database to say, I've started, and it updates the database when it's completed. Or when there's an error, it updates the database to say there was an error. So now you have a separate record of the execution of this task. So that, in a nutshell, is the responsibility of the task section. But this is now powerful because data flow allows us now to launch the task and see what's happening. So where did this come from? Well, there's this need to get batch jobs off the mainframe. The mainframe is great at it, but it's expensive. And people who wrote the original batch job are dead. So you now have to figure this out. So you either learn COBOL, and as you all know, reading code is an order of magnitude easier than writing code. Even I can read COBOL, but I will not try to write COBOL. And hopefully it was written in a way that makes sense, and you can produce a version of a batch program that does the same thing. So people have been doing this, and our boss, Mr. Michael Manella, yes, he started this project to make it simple to create batch applications. And that was a thing before data flow. So it allowed you to create an application that you write something relatively simple, and it will scale that up, and it will put a batch of database transactions together and run this through and check the progress so that you can restart. Because if you've got a batch input with 5 million records and you've processed 2,348,000 and it fails, you don't want to do that again just to continue. You want to be able to restart at that point or the last successful record that you've processed. So the batch abstraction does that. But to make the batch application a citizen in Spring Data Flow, we add Spring Cloud Task to it so that we can track what it did and that it ran. And then, oh, but it is a batch job because there happens to be a record of the batch execution at the same time. And we can now marry that information and present that to you. So what we have to be able to do with these short-lived tasks is we have to be able to launch them. Now, you want to launch them ad hoc manually. There, go for it. Or you want to schedule them. Or you may want to trigger the execution of a batch task from an event on a stream. And we allow you to do all these things without the task knowing about it. Now, we need to make sure that this is going well. So we want to measure the execution time. We want to see the outcomes. We want to have a look at the batch throughput. We want to collect that metrics. All of that is taken care of and made simple and visible. And as I said, if something fails, you want to be able to restart it after you've detected the problem, because as you know, some things you can rerun and rerun and rerun, and it's going to keep failing in the same way. But some things happens to work, especially if you're doing some enrichment and the way the enrichment works is a bit flaky, or you're doing something AI, who knows what's going to happen then. So the bottom line is that we give you the tools to make that thing jump up and down and listen to you without figuring out which box to log into and scroll through logs and restart something and hoping you're passing the correct parameters, etc., etc. So data flow exists to make that world easy to manage. And today, we want to show you how easy that is. We're not going to deep dive on how we build batch apps or stream apps. We are going to show you how we do the orchestration, how we do the composition, because that is something that once you realize that, you understand the value. And there's a lot of stuff that you've already done that you can bring into this world with a little bit of work, maybe even zero work, and you're going to make your ops people happy. Who in the room will call themselves an ops person? Oh, they didn't join us. Okay. Yes, probably not by choice, eh? But I mean, my motto is if you can build and run it, that's when you know what it's really like. There's so many people who've they were not allowed to interact with their system in production. No, you can't touch production because there's a firewall and you cannot log in. You will not know. But we will tell you when it goes wrong, and then you must know immediately why. Isn't that true? But we want to make that easy. And that's why data flow gives you insight into what's happening, and it gives you the tools to manage this in a sensible way. So, are there any questions at this point before we start getting our hands dirty?
Well, we're going to go to streams first.
Okay. Yes?
So is the feature set comparable to Apache Camel? Same.
Yeah, you see, Camel's focus is on all the different building blocks. And when you get to the outside, okay, well, how do you run and manage this? Our view is that we are focusing on the orchestration, and you have this whole toolbox. You can use Spring integration to build various parts. If you go look at the code, you will see our collection of stream apps that we provide. All use Spring integration to get the job done. And those things, there are counterparts in the Apache Camel world everywhere. But the reality is that if you have something that's a testable piece of code that somebody's written, whether they're using Spring integration or whatever to make that work, bring it to us and we will allow you to run it. So that's where data flow lives. And in some cases, it understands what's going on inside because there's metadata available that allows you to configure properties. And like the batch tasks exposes state information and its steps and all that detail that we can look at. So, but as I say, the focus is on management, deployment, orchestration, and managing the life cycle. We don't care what's inside, because if we now add that burden to data flow, the whole thing is just going to be dragged down. So that burden is on the developer of that application. So if you are ready, I'm going to ask my colleague Chris. So Chris and I are the co-leads of the data flow project. He joined in December and I joined in March. And we live on either side of the planet, so we hand over the baton every day. And this has been going on for 18 months, and it has been an absolute pleasure to work with him. And just to make the day bright, Glenn will pop in and say, hola, and the day is better. And we've been moving this project forward. And we would really love to hear from you if you have any problems and any ideas. And if you just want to say hi, that too. So I'm going to let Chris plug in. Yeah, that. Just put it down. If you want to use this, you're welcome. Oh, this.
This part broke. Hold on. Oh, what a guy. Oops. There you go. And I'll turn it down.
All right. Thank you.
Oh, wait. No. I need to turn it down. There we go.
Thank you. All right. A South African and a Texan walk into a bar. Is the
That's not a joke, that's what's happening.
We actually walked into it. Okay. Let me get set up here. So during the lab today, we're going to focus on Spring Cloud Stream and Spring Cloud Task, and Corneil gave us an overview of that. And so I'm going to go peel the onion in the back a little bit on what are we calling a stream application before we get into the lab. Get into the slideshow here. And so when we say stream application, it's what we mean by that is event-driven microservice architecture. And so when Cornell was talking about sources, processors, and sync, those are typically a microservice. And then these little arrows going left and right, those would be events. But the events don't go left to right. They actually, he talked about Rabbit and Kafka. There's a message bus underneath. And so whenever something sends a message to another one of the microservices, it goes down to the message bus. The other listener will pull that up into it and process it, and so on and so forth. And so the piece that's interesting that we want to really go into, Dataflow does really well with Spring Cloud Stream-based applications. That's what it was built for. And so I'm going to go into Spring Cloud Stream. How many people have used Spring Cloud Stream? Okay, so this will be interesting then. This will maybe new stuff. So if we look at this diagram right here, the difficult piece, or the piece I don't want to write, is the to and from the message bus. It's really monotonous, it's error prone. And so Spring Cloud Stream, what it shines at is it has this concept of binders. And so it knows how to take a function, for instance, and write it down to either Rabbit or Kafka and deserialize it and bring it back in as well. And so when you design this is an image off of Spring Cloud Stream's in their docs. And this is another representation of the other slide, really, where you have these inputs and outputs, and you have a binder. And so the binder knows how to write to and from the middleware. And so here's the cool part. So if I have an application and I want to write one of these sources, what I do is I write a Java util supplier, a POJO function, and I put whatever I want inside of it. Spring Cloud Stream and there's another layer I'll talk about, but Spring Cloud Stream doesn't care. It knows how to take the output of that function, which is the leftmost side. It's a source. It knows how to take the output of your supplier and drop it onto the message bus. And so you don't care about any of the messaging middleware. You just create a supplier and it takes care of the rest. Likewise, on a Java util function, that's the piece in the middle. It takes something in from the message bus. It does something to it, drops it back down in the message bus. The sync is a Java util consumer, and it turns around and pulls something off the message bus and does something with it. If you talk to Oleg, who is the lead of Spring Cloud Stream, he said his thing is, I don't care what's inside the function. He really doesn't, because that's not what's cool about it. What's cool about it is that you put something inside that signature, and Spring Cloud Stream will take care of the rest. So how do we know? How does it know how to get to those destinations? How does it know which queue or topic it needs to go to? That's the piece that's not magic. And so there is, there's no free lunch. And so there's this boilerplate config where you can see Spring Cloud Stream bindings, and you see there's a naming convention, this say hello out 0. And I hate to keep jumping back and forth, but if we say this is the sync, say hello, that's the name of the function. And the output, the first output is bound to the destination called 2upper and 0. Well, what's 2upper and 0? That's the name of the function for the processor. It has an input and an output. And finally, the sync is log in of 0. Those are just function names, and then in or out is the naming convention. The last piece is basically tells Spring Cloud function which functions are in the application. And so it can also look like this though. And there's a lot of configuration options that you can do in the Spring Cloud Stream application. When you go from a Kafka binder to a Rabbit binder, you can drop down and end up having to do more specific properties. And so this is one of the areas where Dataflow helps, because if we enter Spring Cloud Dataflow is really good at looking at we have a DSL where you can basically describe that source, processor, and sync. And by looking at that DSL, we know how to go and generate some of that config for you. So you can basically get rid of this config. And the other really piece of this config, it's really delicate, it's really brittle, because if you don't get your input wired to your output, wired to your input, wired to your output, you're like, where's my data? And so Dataflow has basically three modes of interaction. There's a shell where you can go to a command line and basically do all the operations you can do in the UI. There's also a REST API to interact with it. And the shell and the UI both use the REST API. For our purposes today in the lab, we're going to stay in the UI. But check out the shell sometime as well afterwards. And so, lab time. Yeah, if anybody didn't register at Spring Academy, does show of hands of anybody who didn't get registered or still needs to? Did you come in late, or did you see can you go to Spring Academy and then register an account? And so, wrong one. Okay. Let's see. I'll go ahead and get started.
So this is where you can find your labs here.
Yeah.
So go to spring.academy.
Yeah,
So
good
what you're going
point.
to see here on the lab here is go to spring.academy/courses, spring-getcloud-dataflow-s1-2023. This is a private course just for you. So here is where we're going to be doing our labs. And right now we're going to have Chris kind of walk you through the first section of the lab so you kind of get a feel for it. And one thing I want you to know is y'all are now going to be, the key word for Dataflow is orchestration. So you're going to be orchestrating and creating a series of apps. You're going to create and orchestrate a stream, and he's going to introduce that for you.
Yep. Thanks, Glenn. So did everybody get to that? Is everybody in the lab? Okay. Just raise your hand if you're not, and somebody will come around and help out. Cool. Okay, wrong one. That means not that. Whoa. Okay, so it's going to look like this. I'm going to also go in the lab with y'all. We'll kind of walk through the first one with y'all, and then we'll let y'all loose on the other 5. What does that look like size-wise? Let's see how big that is. Can't see it.
Anyone else have any issues? I have issues all the time, so don't worry. It goes like this. All right, I'm going to go ahead and say, let's get started, Chris.
Cool.
And folks, don't worry, follow the line. Just raise your hand and use this. Okay? So Chris, proceed.
Cool. Okay. All right, here's our agenda. We're going to go through, like I said, talk about streams, do a little stream lab, take a break. Glenn will hop in and talk about task, do the same thing, and then we'll do a lab with task. And so click the Spring Cloud Stream Lab link, and let's start the lab. And just be patient with the loading screen. It'll take a second to load up. Okay, cool. So a couple of tools we're going to use when we go through here. Y'all can see it on your own screen as well. On this, I'll call the left-hand side the left-hand side nav bar going forward, and then on the right-hand side we have the terminal and the data flow admin. We've talked about the data flow admin, the UI. It's right here. If you click over on the terminal, you'll see it pop up. You've got a list of applications there. That's our application screen. And then back here in the terminal, one of the things we're going to do, we're running on top of Kubernetes. And so what we're going to do is there's a tool called K9s. And what K9s is really good at is it's a little graphical editor, a web-based UI to interact with the Dataflow server. To interact with your Kubernetes cluster. Here's a couple of commands and tips as we go into K9. So here's what I'll do is I'll come over here. If you want to come in the terminal and type K9s, you'll see this pops up. Let me give some more real estate here. You'll see this pops up with a list of pods. And these are the infrastructure for Dataflow. There is a database for Maria, Rabbit MQ for the messaging bus, and then a Dataflow server and the Skipper server. Those are the two pieces of Dataflow. There's server and there's Skipper. Skipper handles the deployments. And so you can go arrow up and arrow down through here. And then if you hit enter, it drills down into the container view. If you hit enter further and then hit 0, you'll see the logs. And so we'll do this multiple times. Let me go ahead and escape out there. Let's see. Okay. Okay, so some concepts. App registration. So what we're going to do is we're going to go through and actually register some applications. And when we say applications, it's our toolbox, basically. We have these prepackaged Spring Cloud Stream applications that you can use to build up your stream definitions with. And then we have the concept of stream definition. Let me see. Hey, Glenn, do me a favor. Can you come up here and run through this real quick?
Sure.
Just do the,
Okay. There you go. So what we're going to cover right now is the basic concept of Spring Cloud Dataflow. So what we're going to talk about today is really okay, the first thing we're going to do is when you create a stream application stream, the first thing we're going to have is a concept of a definition. It's where we define what the flow of that stream is. We're going to declare what applications are a part of that stream. And then what we're going to do is each time we set up an application stream, we can actually come in and set properties. So that is a stream definition. And we at Spring Cloud Dataflow have a DSL, a language that allows you to declare that definition, but also we have a graphical editor that allows us to do that. Now, once we have declared that definition and we have saved it, we're going to show you, this is being part of your lab, so don't worry. Once you've declared your definition and saved it, what you're going to do next is you're going to actually deploy that stream. You're going to actually take that stream definition and it's going to deploy that directly out to your environment. And we're going to show you how that's going to look like in Kubernetes. Now, that stream, once it's up and running, it's just going to allow the data to flow through it. It's going to be really awesome. But there's going to be a time you're like, you know what? This stream needs to go away, and we undeploy it. And what that means is the definition remains, but the applications that are deployed to my Kubernetes instance, well, they get turned off. They disappear because it ends those pods. Then lastly, you say, well, that's great, but I don't need this stream definition anymore. I can actually go in and click delete and delete the definition, at which time it also, if the stream is deployed, will undeploy that stream. So the basic concept here is I can create and deploy a definition for stream, deploy it out there. That stream will remain up until I take action to what? Either undeploy it or I actually destroy that stream definition. Now, the thing that we're going to do is we're going to have a pattern to this. So again, when we go into our application, we're going to create a stream definition, we're going to deploy it, we're going to wait for the stream to actually come up and get into a good condition, and then we're going to actually send data or events through the source of the stream. Remember, it's source, processor, sink. We're going to send data through that source, and it's going to make its way through to the sink. And then once we've done that, we're going to actually view the data after it comes out, and we're going to make sure that that data actually makes it through. And then when we're completed, we're going to destroy the stream. We're going to actually create about 4 streams today, and each one is going to add on to what we've learned from the previous. Now, Chris is going to pop up and take up after here because he says Glenn is vamping too much. And remember one thing about Glenn, he's long-winded. And can you just set, whoop, popped out, that's okay. Can do sound check?
Checky check. All right. Sorry, I had to take an important business call. No, I'm kidding. Sorry about that. That's embarrassing. Let me see. Okay. So I guess, Glenn, you went into, okay, so we're on register apps.
Yep.
Has everybody started registering apps yet, or were you just talking about it?
Just talking about it. We're about to start. You're going to take them from there.
Cool. And so the apps are basically, that's your palette. They're Spring Cloud stream-based applications that we maintain. And so somebody asked about, is it comparable to Apache Camel? I'd say we don't have as many probably integration points as Apache Camel, but there's a good handful of some basic stuff out of there. And we're doing a session tomorrow on building a custom app for data flow. And it's really a Spring Cloud stream-based application. So it's pretty simple to do. And so, but we need to first register those applications, because if we come back here to the data flow at UI, you can see that we have nothing in our toolbox, no boxes to drag together and make arrows go left to right. So let's go here. Everybody go into the data flow admin UI. And then if you go to the applications tab, over here on the left side, we have a lot of information about a handful of apps we're going to use. And so when we register an app, all we do is tell Dataflow, here's an application named foo, and you can get its container and some other information at these coordinates. And so it doesn't actually create a stream, it just defines a stream definition. And so let's copy that out and say, add applications. Oh. Cool. And so if you go add applications and go to, and y'all can also go along at your own speed. Everything I'm saying is on the left-hand side. We want to choose import applications from a properties file. And when Glenn goes, he's actually going to go through and register it piece by piece. And so if we look at one of these, really what it says is, okay, there's a source. It's called HTTP, and here's where you get its Docker container from. And here's where you get its metadata from. And so when we click import, yay, now we have building blocks, right? We have 2 sinks. You can filter by type. We have a source called HTTP. We have 2 processors, filter and splitter, and 2 sinks, log and file. And so what we're going to do, Glenn mentioned, we're going to take the most basic 2-node stream. We're going to define it, deploy it, send data through it, watch what happens, tear it down, and then we're going to wash, rinse, and repeat and do that for 3 nodes, 4 nodes. And it's really to do some repetition so y'all get the idea of what it, how to get around inside of the data flow. So let's go. Yeah, this number 6 just talks a little bit about each one of the applications. The HTTP one is going to be our source throughout the whole lab. And what you do is you just basically post data to it, and it's going to send it down the stream. Let's see. Filter is going to take the payload and say if it doesn't match the criteria, it's going to drop it. Splitter is going to look at the payload and say it's going to have an expression for a delimiter, and it's going to say, oh, there's spaces. It's going to turn you into 1 or more events. And we have sinks for a log. It's going to write it to a log file. For a file, it's going to write it to a file. So they're fairly simple apps, and it's really just to illustrate how we wire them together. Okay, so now that we have them here, so what are we going to do with them? Let's see. One thing you can notice also that's interesting is there's a column called Spring Boot version. And so the apps that we registered, there was a version number on the end. It was 321, and those are our Spring Boot 2.x based apps. So we're going to go through, create a basic app using Spring Boot 2x. We're going to come back, update it to use the next version, and it'll be the Boot 3x version of the apps. And we'll hit update, and you'll see that it just upgrades it automatically to Boot 3. And so, yeah, at this point we've done nothing but register. There's no services running. It's just a blueprint, just metadata that says here's how you would create this, or here's what you can use to create stream definitions with. Okay. So let's go ahead and create a stream definition. So if you come in here to the streams page, the streams view, you just click the left-hand nav, streams, and streams, and click create stream. So you heard us mention about the DSL, the stream DSL. And so what it is, it's a domain-specific language that is modeled after the Unix, pipe A, pipe B, pipe C pattern. And so it goes like this. So we say HTTP log. And you can also notice that this visual editor is, as we type this DSL, it starts rendering whatever the nodes are in the stream. If we delete this, we can also come down here, excuse me, and we can do a little bit of WYSIWYG editing and go HTTP, and then we can drag the log over here and then connect them like this. And you'll see that up at the top, the DSL got generated. Using the straight DSL is always much faster than trying to drag the arrows back and forth. Okay, so at that point, we're going to click create, give it a name. I'm going to call it stream 1. Cool. And so again, we haven't done anything here except for create the blueprint, the definition. And if I drill in here a little bit, click on it, you'll see some details. There's not much details yet. It's just the name of the applications. Once we deploy and we come back in view here, you'll see there's a lot more details. And so the next thing we want to do is actually go and if I get ahead, that's okay. Y'all can just go along through the instructions on the left. Let's go back to streams. There's this little action menu to the left, and we can now click deploy. Okay, so the first thing you're going to say is, what is all this? The screen is very busy. And it is. And this is where you go and set properties on the stream before you deploy it. And the way that you can decipher this, there's rows and columns. And up at the very top, this row is the generic deployer properties. Then you have deployment properties. These are things related to Kubernetes. And then you have application properties. And for the lab, let's focus on the application properties. So if you just look at this last row, and then if you come over here to these columns, you'll see there's HTTP and log. Those are apps. And so when you create an application here, you can publish metadata that says, here's my app, and here's the properties that you can set on it. And by having that metadata, when you come in here into the deployment properties to deploy, it'll automatically pop up. So if I click here, for instance, you can see that the HTTP app has some properties you can set. We don't need to set any of them because the defaults work fine. And so for the first stream, we're going to leave the properties alone and just click deploy. Great. It kind of looks just like it did right before we click deploy, right? It doesn't really, there's a status indicator over here, but if you drop in and click the details, you'll see there's more going on. And there's some deployment info and there's some runtime info. And so if I go down to runtime and say, look at log for log, you can see we're running Spring Boot 2.6.8 right there in the banner. I don't know how well that's coming through, but you probably see it there. And we go to the end of the log, and it's a typical Spring Boot app that you've seen before. And it's just sitting there doing nothing, but it is deployed. And so the other interesting piece is let's look at what happens under the hood. We say we're running on Kubernetes, right? So if we come back here to the terminal on K9s, now you'll see that instead of those 4 infrastructure pods, there's an extra 2, 1 for each node in our stream. And so here we have, and the naming pattern you can tell is I named mine Bono Stream 1. And so there it is. That's the HTTP app, and then there's the log app. And the naming pattern is the same. It's whatever you named it, whatever the name of the app is, and then the version number. So let's look in a little bit to the log app. So that's the container view. Enter again, you get into the log view. Hit W, it word wraps. Okay, it's just sitting there, it's starving. There's no data going in, but the apps are there and waiting to do things. So let's feed it some data from the HTTP endpoint. We have a script out here that we've created called curl, or send data, I think it is, curl data. All this does is because the HTTP app, every time we redeploy it, it gets a new IP address. So instead of having to try to dig through every time we do this and get that IP, it just goes and asks Kubernetes what the IP is. And then it just does a curl to it and sends the data through. And so let's do curl data, do quotes, double quotes, and let's say foo bar za. And sending data. And so you can see over here in the log up above, it just sent the data through. We're not doing anything exciting. We're taking HTTP post and we're dropping it out to the sink. So, but if you can imagine the diagram before, which looks like this, when we come here and show the data pipeline, these are kind of the diagrams we've been talking about, sources and sinks. And so we just basically wired up our most basic source and sink. And one more interesting piece, you can also come in here and see the log from the UI. You don't have to drop down into Kubernetes. We just want to show you all that we're trying to drill the fact that these pods or these nodes in the stream result in actually running services. And so you can get to the very end here and see that foo bar za. And so, yeah, we did the first lab. Let's see. Where is everybody at on this right now? Should we take a little pause? What's that? You're waiting on the log to show up? Oh, hit the 0. Does it say waiting for logs? Okay, yeah, if you're in K9s and it says waiting for logs, hit 0 and it pops it up. It was in the tips and tricks, but I ran out before I could explain it to y'all. Cool. And so I'll pause a little bit before I talk about them. We're going to do one more thing together, and then y'all can do the last 3 sections on your own and just raise your hand and we'll come down and help out. So before, what we did was, just to recap, we registered the Spring Boot 2.x based apps. We built a stream out of it, deployed it, sent data through it. What we want to do next is go and register the 3.x apps, come over there, update the stream, drop down the version, hit go, and upgrade it to the new version of the streams. And so first thing we want to do is come over here to the stream and undeploy it. So there's operations of undeploy and destroy. Destroy undeploys it and deletes the stream def. Undeploy just undoes the services and basically removes those, but it leaves the stream definition around. So let's go back to K9s. And if we escape out, you'll see that we're just back to our 4 nodes, the infrastructure nodes, pods. And so I'm going to come back to the admin. We're going to go back to that same exercise we did before of inspect. Yeah, I'm kind of just flying through here. Let's see. It's the same thing we did before. There's something to cut and paste, except for you'll notice the version numbers out here. They're not 321. They're 400RC2. And they also have this other little interest. What's that? An extra line? Oh yeah, well yeah, that's what I was just going to say. There's another property at the end called boot, type, app name, and then boot version. If you don't specify it, it's 2, but when you want to register boot 3 apps, you have to specify that property. So what we're going to do is we're going to copy that out. We're going to go back to the add applications. We're going to go through the properties file method like we did before. I'm going to paste it in, and we're going to click import. And you'll notice we didn't have to remove the old apps. We just imported right over them. And what you can see that's different though, there's this little number 2 right next to the version. So you see 321 because that's the default. But if you drill in a bit and you say manage versions, you can see there's 2 out there, the 321 and the 400, boot 2, boot 3 respectively. Okay, so let's come back to our stream, and let's do let's deploy it again. When we deploy it, we have the opportunity to change those properties again. And so what we want to do is come over here to the version selector and pick 400, 400, and then deploy. And so the theory is that now when we go through that same exercise of go look at our logs, see what they're doing, when we look at the Spring Boot banner, it should be 3, not 2. And so we can look at it either here via the runtime. And there it is, 311, right? And so we didn't really upgrade our application. Those applications have already been upgraded. We're just using them. And so if you were the author of log sync, you would have to publish a version that ran with Spring Boot 3. Like there's a few things you'll have to do, but if you're just using the toolkit, you don't care. Somebody else did that for you. And so both versions are available. And so let's go check it inside of K9s again. Okay, when it's red, then you say, whoa, what's wrong? It's just, if you've ran Kubernetes, you know that it's just the pods coming up, and give it a second. Okay, let's go through the same exercise again of looking at our logs. Hit 0W, wait, one more. 0W, okay. Let's send data through just like we did before. Curl data, foobar za, and well, we should see the same exact thing. Nothing's changed. And yeah, we did. Okay, so this stream is pretty boring. It's HTTP and log. So what we want to do next is, if you look on step 5, we just want to go through and add some functionality to that stream. Put another block in there, if you will. And so the first thing we need to do is, so please, after we do each lab, it's important that we go through here and click destroy. There's like the relationship is each one of those is pods in Kubernetes. And so if we just left them laying around and kept going and kept going and kept going, you get the idea. There would be lots of pods, lots of resources. And so if we come back here to K9s, you can see that now the stream defs are gone. It's just the infrastructure. And so, boom, we're ready for the next lab. And so this is where I'll step away and let everybody else continue with, the stream with 3 nodes. If any of the instructions are not clear, just holler and we'll help out. Or if anybody gets stuck. Cool.
So at 2:45, that's when we had the planned end for the lab. So what, and it was 2:45 to 3 o'clock for a break. So what we're gonna do is we go ahead and skip the break,
Okay,
continue down the path, and then if people need to step out to go to the restroom, we can, okay?
cool. Sounds
So
good.
that we're all adults, and where we need to go,
Got it. You want me to announce that?
yeah, so what we're gonna do is this time we're gonna go till 3, and then don't worry if you don't finish, it's okay, we'll continue the course, and then we'll stay after the course.
Got it. Yeah, so we're running a little bit behind. So if we were originally going to end the streams lab at 2:45, we're going to go ahead and go to 3. And don't worry if y'all don't finish it and y'all want to stay behind after there, we'll be glad to stay behind if y'all want to do more of it. If we were going to take a break at 2:45, but if you need to go, if you need to take a break, just get up and take a break. It's fine. Otherwise, we're just going to keep going through it till 3. Maybe because of the time crunch, maybe I'll continue through it and just so people can watch along too as I go and do the labs as well. Here, I'll come down there.
What
Yeah.
does it mean when it can't find a log?
Is it what
How
it
did
say?
it get-
Waiting for a log. What's it on right now? What are you?
That's what you're saying. I can't find this log that I created for that stream.
Hop back out, like select up inside of there, and then click escape out of the.
Escape.
When you get back in K9s, yeah, and just click here. Yeah, there you go, and go back. And so, what do we have running?
The stream that I created.
Okay, and that's what we're trying to do the log on.
I think so.
So yeah, enter it, and then go again, and then hit 0. I think the view was still stale on your last pod, and so it's like I don't know what this is. You have to go back out and.
Yeah. Being the old. Yeah. Okay. Makes sense. Thank you. Everything else good? Yeah. Going through. Oh, quick question. So this entire environment, this Spring Data Flow Spring, what if this console was working? Something we need to deploy?
No, so like where are we working right now? This is inside of the Spring Academy platform.
Sure, but if I put this where I'm at, I'm not going to be Spring Academy.
No.
I'm assuming create all this service.
No, you don't need to do all that. So you don't need those 4, right? So at the end of this, we're going to go and talk about how you install this thing for you.
That's all it is.
You can talk about that stuff.
Yeah, because we're doing something similar, but I'm just using it for annotation for calculus and stuff. What we build on services, I'm assuming that's similar, except it's just more friendly.
Yeah, so you can, if you look at Spring Cloud Stream, you can do the same thing we're doing here by yourself. You don't need data flow. It's just going to make it make your life easier and better, especially whenever you start, when you have 3 nodes, who cares? I can do this myself. When you have 100, you can start doing updates and rollback.
that's where everybody starts coming in and stuff valuable.
So is something like a data team can use, like coordinated with an app dev that actually gets services, and then the data team can then control it and say, hey, we're going to type all these things and here's what's available. Is that kind of like what it is intended a little bit?
Yeah, exactly. And so if, and you can actually combine the Spring Cloud Stream with Spring Cloud Task, because there's actually that will go and even if it's free, it's not so you can get some complicated flows, and that's not the ideal way. You want to have flows, but yeah, depending, because it's just think of Spring Cloud Spring, that's Spring Cloud Task or Spring Batch apps. That's where it's real. That's where it works really well.
Yeah, we do it. We do a ton of data, but it's strictly the service. Kafka listener, publisher listening, and pull that in different things.
Yeah,
Just not this way.
right. So it's going to use Spring Cloud, so basically,
Yeah. Okay, but it's using that underneath them, right?
It's just all uses Spring integration. That's
Yeah.
if you go down to the base,
Okay.
which is here.
Cool. Yeah, thank you.
Yeah, you're welcome. Y'all get it registered? Yeah, cool. Let's see what we got. Huh, go to the terminal. Let's see if
Yes.
So what I'm going to show you on the front is I'm going to this is a Java jar. And basically, I'm going to show you the data flow that's going to show you POW get, sniffer, you get data flow. Start the data flow, set up the government. So we'll find that. We don't have all the up in the front. Thank you. That's a real top question. Okay, can I steal the lavalier? This is batch lab is going to be, so the batch lab is really 20, so what it is it's 3 o'clock. We end at 4. Thank you, folks. I have good news and I have bad news. Well, actually, I have good news and I have bad news and bad news. Who wants the good news or the bad news first? All right, well, here is the good news. You're going to hear about batch. Don't cry. Okay? So what we're going to do is here, real quick, let me go ahead and bring this act up to full screen. Okay, the bad news, you got to listen to me for the next 15 minutes. Okay, and that means that if you're listening to me for the next 15 minutes, the good news is you might go to sleep. There we go. No, that might be two good news there. All right, so here we go, folks. What we're going to do is we're going to talk a little bit about tasks. What are tasks? My gosh, does that work? Yes, it's work. It's a lot of work. It's a ton of work. No, tasks are ephemeral apps. They're actually microservices. My gosh, can you have ephemeral microservice? Yeah. They basically are going to have the same concepts as the 12 factors. They're going to be able to come in and launch. And when they launch, they need to do some certain things like, okay, I need to have configuration. I need to be able to have a place where I have my logs, blah, 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 follow the full 12. So I want to have microservices, but they're ephemeral. They wake up, they do something, they go back to sleep. And I mean, to go to sleep, they terminate, they do their work. That is the basic premise of a task. Okay? What comprises a task? Usually a task is a Spring Boot application, right? And it's not like a web app that kind of wakes up and stays alert and does until an external agent like myself terminates it, right? That's called a long-running process. If we look at our stream apps, those were long-running processes. An ephemeral app launches, does its work, and terminates. You can, if you're Spring Boot savvy, that is an application runner or command line runner, okay? Now, what makes a Spring Boot app different than that is have an application runner or command line runner than a task? Well, let's go look at that. So I was going to talk about why tasks, but we'll go ahead and do that now. But the difference is, and we'll talk about that in a second. I jumped ahead of myself. I got excited. So why tasks? Tasks are really good for handling large data sets, right? We're going to be reading 5 million records, like Corneil said a few minutes ago. And, so we're going to be reading and processing and managing and enriching like 5 million records, reading from a massive database and writing out to another maybe messaging service, or reading from this flat file, processing it and make sure it goes into the right database. It's also done when you're doing heavy computation. I'm seeing more and more people push heavy computations to what? Tasks, okay? Things that wake up, do it, and then terminate. And you can even say, well, is people still taking it seriously? Absolutely. The Kubernetes have created a work group just for handling batch jobs, right? And it was started last year. So we're starting to see this merge. Glenn is bringing in tasks can be batch jobs, right? So can a boat app be a batch job? I saw a nod. You win the prize. Yes, I get you a pair of socks just for nodding. I appreciate that. Just come see me. I got a pair of socks for you. So they're spring socks. They work. Okay, so here we go. Now, when we talk about this, we see that there are business cases for handling batch apps, right? What we saw with the streams is the ability for us to bring up a stream, handle events, be able to capture, let's say I have a case where I'm actually I'm running a sporting event. I want to capture impressions, right? And I capture these impressions as they're coming in from social media. And as these games, let's say it's a baseball game, and as a baseball game goes along, I want to capture these events. I want to take these events, I want to store them in a database, right? That's going to be our base stream. Take these events, transform them, enrich them, and store them in a database. Okay, but with a stream, I can go in and tap off and then be able to maybe tap off of that main stream and then take that data and then say, hey, who wants to, maybe I'm a pizza company and like, who's saying pizza, hungry, maybe our corporate name, maybe our competitor's name. And then we take that as filters and we're like, hey, we've seen where 5,000 people have come in and talked about this in the last hour. Send out go ahead and send out a commercial that says, look, if you order in the next 15 minutes, you get 30% off with this special code. That's valuable. That's what a stream does. Stream says, I can take these events, do something with it right now. But when I'm storing all this data through the main stream that's saying, during this event, I captured all this data. I want to generate reports. I want to do research on this. That's when task kicks in. I can take and read all that data that was stored through those streams and then generate reports, do research on it, really dig in and get value from that, right? Because we could be taking millions of impressions in just during the course of a significant event. So tasks have a purpose. Streams have a purpose. Then you decide where you're going to use them. But tasks have responsibilities. Yes, not only do they have to do that heavy lifting, all that work, but they also have to do what? They can run anywhere within our infrastructure. They have to maybe do the following. Record their state. How did they end? When they ended, what happened? Did they terminate successfully? Did they not terminate? Did they get hung? When they did terminate and they did terminate successfully, was there a message? We need to be able to capture that. I also need to be able to monitor my task apps. When my tasks are running and they're doing their work, I may want to be able to have them send out information to like an observation framework, like a Datadog, a Wavefront, Prometheus, InfluxDB. I want to know how my app is doing. So there's two levels. One, I want to record their state to a database somewhere so that something can use it and have one common place to view it. But at the same time, if I have systems out here that are tracking and want to know what's happening in my system at this time, they should be able to do both of those. Then finally, my task app needs to talk with other apps. What? A task app, a batch app talking to other applications? Why? My batch app is running, it's finished, meaning it may be doing a billing run. And when it's a billing run, what do we want to do? We want to take and tell somebody, hey, generate, we've run the bill runs, now I want you to actually send out the bills, right? So I want to be able to maybe, when the batch run ends successfully, send that message out to the billing, to the enveloping system to say, here's the information, cut those bills now, all right? So we can see where a batch app can actually take in turn, kick off other processes downstream. So it needs to be able to communicate that. But geez, that is a lot of what? Boilerplate code. Who likes writing boilerplate code? Who gets promoted for writing boilerplate code? Who misses their children when you write it? Okay. Well, all right. So guess what? Spring Cloud Task. It says, don't worry about that. We'll take care of that for you. So when it's time for you to be able to write your applications that are ephemeral and you want to have these type of services and plus a lot more, bring in Spring Cloud Task as a starter dependency, okay? Now, you say, all right, Glenn, that's really awesome. I think that's a lot more boilerplate. Guess what? It is not, because all you have to do is go to start.spring.io. And in this case, we bring in task. And when that task is running, I want it to record its state, how it ran, how it behaved to a database. And we'll show you why Dataflow needs that in a minute. And I go to start.spring.io. I generate my app. And then I have just my application runner like I advertised right here. It just says, hello, just print out the new date. It's just printing out a timestamp. But what makes this a task? Just adding a dependency? No, I made sure that you have to add this little annotation that says, this is a task, at enable task. You're done. Yay, you read a task. Y'all don't seem that excited. Batch is good. It's all right. You're going to admit it. Come on. I'm going to tell Mahmoud, and you're going to get in trouble. He's the batch lead. All right, so we've talked about launching apps, and Corneil revealed several ways to do that. You could schedule it, right? You can launch it ad hoc. You can actually have streams to kick off batch jobs. Yes, streams kicking off batch jobs, taking over the world. Oh my gosh. But we also discussed how tasks need to talk to other systems. Not only do we want to save their state how they run, and to be able to store that to a database so that no matter where it ran, we can go to one place and check how it did, or also be able to communicate that type of information, to some kind of observation framework. But there's more to it. Let's go back to what he said earlier. He says, I'm running 5 million records, and at record 2 million. It fails because what my batch app is doing is reaching out to this system over here to get data to what? Enrich the data. So it's enriching the data, it's happily going on, and that service goes down. My app, it's retrying. Eventually it says, it's gone. I'm not going to sit here and hang around. I've got other things to do. And then the batch app or our task ends right there and says, okay, I'm not going to keep going. But that means I processed 2 million records and I've got to, what do you mean? I'm going to reprocess 200? No, I want to have something to restart. I want to pick up where it left off. That sounds like a lot of boilerplate code. And remember, who likes to write boilerplate code? Good. I don't like those hands go up when I see that, because then I have to take you out in the hall. We have to have a talk. All right, now, so there's more than restartability, right? When I write a batch app, I've got to have transaction support. We want to have rollback, right? We want to have this kind of control. Who likes writing transaction code? Dang, y'all are really, we need to talk. We'll talk after in the hallway after this. Okay, no. Who likes writing the reading write app code? Who likes to write the parallel processing code, the retry skip logic? I'm not seeing hands go up. That's good, because guess what? Spring Batch does that for you. Spring Batch's main primary goal is to say, look, do not worry about writing that. Use the builders it provides. It gives you builders that says, look, when it's time for me to design that job, I'm going to have a builder that's going to design the flow of that batch job. That batch job is made of steps. Each step has a builder so that I can do the following. I can have the batch builder to be able to design these steps where I have batch job. It says, I want to build step 1. Step 1 is successful, run step 2. Then I want to run step 3 and 4 in parallel once step 2 is done. Then what I want to be able to do is take, and when I build out that step, do I want to write the code to build that step? No. I'm going to have other builders to come in and say, I want a builder here that reads from a flat file. I don't want to write that code. I'm going to use the builder to specify how it should read that flat file. When it's time for the writer and it's writing out to a relational database, I'm going to have a builder that says, hey, I want to write to this database in this way, and this is how I want it configured. It will do that. Oh, what if we're using Mongo? You're in great shape. If I'm using the key value store, you're in great shape. What if I'm reading from Mongo and writing out to a Kafka? You're in great shape. Spring Batch has these builders already for you. You're ready to rock and roll. Now you're saying, well, Glenn, you talked about that failure stuff. Right in the middle, it just goes boom. And I'm going, yep, has that ever happened? Oh man, I got to hurry up. Yeah, believe it or not, I am behind. Okay, what happens if step 2, well, that's cool. All right, well, let's say step 2 fails. Oh my gosh, we did probably step 1 and step 2, we did step 1 and step 2 fails. Spring Batch out of the box says, look, oh, you ran it, it stopped here because that service is down. Well, okay, the service is back up. I'm going to pick up, I want to start running at step 2, and Spring Batch will say, okay, skip 1, go directly to step 2, and you pick up and you run where you left off at. You say, well, Glenn, we have special logic that we need to know what happened in that last one so we can restart properly. Spring Batch gives you a context out of the box that you can insert values in so that when you restart, it can say, oh, what was my state? Okay, I need to do this before I pick up and start running again. Batch gives this stuff to you out of the box. So when it's time for you to write a batch app, do not write boilerplate code. Do not make me cry. Make my mood happy. Look at Spring Batch. Now, you say, Glenn, where do I get the data on data flow? You're going in here and you're listening to Glenn being boring about his talk. Go to dataflow.spring.io. It's a lot more exciting. It will tell you how the various ways in which you can deploy a Spring Batch, Spring Cloud Task, deploy your streams using Dataflow. It even gives you samples on how to do it. So dataflow.spring.io. Not as good as start.spring.io, but pretty daggum good in my own self, if I must admit. Now, Glenn, we just played a lot with Kubernetes, but I want to do this on my own local machine. I want to start my own local machine. I'm 2 minutes late. Is that okay? All right, so here we go. All right, Glenn, I wanted to run this on my local machine. I see you have Skipper. It's beautiful. You have Dataflow, but I want to be able to run this on my local machine. How do I do it? Now, the first thing we're going to do is we're going to do a Docker PS. And I'm not going to lie, in the background, you're going to see I have a RabbitMQ running in my own local Docker instance. I have a MariaDB running in my own local instance. Okay, and you can see I have Minikube out there. Don't worry about that. It causes nightmares to children at times. Don't look at that. We're not deploying to Kubernetes, okay? It's on my local machine. All right. So we see that those are running. So the first thing I'm going to do is I'm going to start Skipper. There we go. Skipper starting. Okay, part of what you see on dataflow.spring.io is it's going to tell you where to where to get these things, where to pull them down, right? And I already had that environment pre-set up. You're just like, Glenn, what else do I need to set up my environment for Dataflow? Oh my gosh, and I'm like, well, you're fine. First thing we're going to do is I got to tell it where my database is. Please ignore my password here because it is password. We'll scrub that from your memory, okay? I'm lazy, but it's on my local machine. That's okay if you want to break in. Please don't. All right, now what we're going to do is we're going to do what? Java-jar, Spring Cloud Dataflow, server.jar, go. Now Dataflow is going to start. Now I'm running it on my local machine. Okay, there's Dataflow. Hello, Dataflow. You saw it go past there. All right, so Dataflow is up there and running. It's really good. And then what I'm going to do here is go to what? Dataflow. Now we've done deploying of tasks. That's good. We love that. It was a lot of fun. We're going to do this, we're going to destroy. Now you're going to do something a little different. In your lab, you're actually going to register an app a slightly different way for your batch. It's the same thing as you did before for streams. You're going to see a lot of things that are very familiar, right? And you're going to see that as part of your lab. So we're going to go ahead and skip the ad registration part because you're already experts at that, okay? So what we're going to do is I'm going to use the timestamp app that comes with Dataflow for free just to kick the tires, have a little bit of fun, okay? So what we're going to do is we're going to create a definition. This definition is so massively different than what you've done before. You're going to be like, my gosh, how can I retain all this information? And it's not. It's going to look the same. The way you deploy your streams is the way you're going to deploy your application or your task. It's actually pretty cool. So we're going to zoom in here. Woo, look at there. And I happen to have a timestamp task. And I say timestamp. We scroll down, and there we go. Okay? What does that look like when I launch it? We're going to create that task. This is creating that what? It's not a stream definition. It's a what definition? Tell me. Task definition. Thank you. Okay. Okay, all right. Sorry. Okay, I can do this. I can do this. All right, so we're going to go timestamp 2, because I already had a timestamp 1 out there. Did I already delete it? Nope. Oh, yeah, I did. Okay, cool. I should have went timestamp 1, then you ought to have been impressed like I did practice it. All right, we're going to go here. We're going to what? Deploy? Heavens no! We're not going to deploy. Deploy means you're going to deploy it. It's going to stay out there until I tell it to stop, right? No, we're not going to do that. We're going to launch a task. Why? Because tasks what? Start, and then what do? On their own when they're done. Stop. There you go. Okay, folks. Coffee for everybody on the Explore. Okay, no, there we go. Okay, we're going to explore. Oh my gosh, let's see. What do we do for properties? Looks the same, right? This continuity, right? Again, the way you orchestrate streams is the way same way you're going to orchestrate tasks. It looks very much the same. We're going to click that, launch that task. There it goes. It is beautiful. It's even given us like some of the properties redacted so that we don't know everybody's top secret stuff. That's really good. Okay. But then we go to task executions and we see, oh, cool. It completed. From here, I can click this and scroll down and see what all the good stuff that happened. Now, I'm not going to lie to you that normally you could click log here. We can do that here and see what it did. Now, in your environment, it won't work today because guess who did not set it up properly? So you can't do the logs today on your samples from the demo. I apologize, but setting up by default, usually it works. I screwed it up. Remember, folks, if you actually go to look at what is Spring Talk, I was supposed to say S1 demo, and it came out S1 domo. That type of mistake, okay? So I'm just letting you know right up that Glenn is not perfect. Now you say, okay, what else is different than this? It stopped. What else can I do with it? Well, I'm like, oh, heck, I'm just going to launch it again. I'm going to launch it again. Okay, you can do this, Glenn. Launch. The difference between a task and a stream is a stream, you run one. Okay, task, you can run. What if the other one's not done? It doesn't matter, run it again. Okay, that's up to you. It depends on what you need. And now if we go to task executions, you'll see what we have 3 runs, right? Same principles, same feel. Okay, you're like, Glenn, one more thing. Glenn, I know that this is boring, but I want to tell a story to my children to help them go to sleep, right? Okay, well, the way you can do that is the following. Much like with streams, we can actually create workflows with tasks, and the way that we can do that is go here. Let's go and do zoom in. We're going to put timestamp here, boom, and we actually have another application that we use as a sample called timestamp batch. Oop. And we can do this. Drag, and drag. Now what's going to happen? Dataflow is going to launch timestamp. If it's successful, it's going to turn around and launch timestamp that batch. Okay, create the task. We'll call it TSB1, or just call it TSB. There is no other. Okay, there we go. Create. And we see that does TSB. We launch that. And then what I'm going to do is just do a little setup here. I'm going to go to the properties. And I apologize, folks. I know I'm supposed to be doing this really quick, and instead I'm sitting there making it arduous and long and boring, and that's deployment properties. Sorry, that's my bad. Let me go back here. I'm going to launch it again. See, they're clapping over there, right? And I'm sitting there making y'all go look at properties. Come on, Glenn. You're just mean. All right, I'm going to try this one more time. Is that deployment properties? Okay, don't worry about it. We'll just launch it right now. Okay, I'm nervous, and I make mistakes when I'm nervous. Okay, so now what we're doing is we're launching this app, and what we're going to see is that Spring Cloud Dataflow is saying, I'm going to launch something called the Compose Task Runner, and that Compose Task Runner is going to manage the execution of that stream, or sorry, that workflow. And as we hit refresh, okay, we see that it ran the timestamp. We see the timestamp is complete. It was successful. We see that it returned a 0 exit code, right? And then we're going to turn around and see where we keep hitting refresh. It's going to run the timestamp batch. We see what is complete. And within a couple of seconds, we can see what? That it's going to complete in a second. Don't worry, it's just stubborn. It doesn't go to sleep. So it's done. But then I can go to the job executions here and actually view this and see what did it do. And here I can actually go in and view what did that TSB do. Now, folks, you will go to your labs now. So you're going to exit out. you're going to leave the Streams lab temporarily, I apologize, and you're going to see there's a batch lab. I'm going to give you a choice here. You can continue working on the Streamlabs and stay there. Now, mind you, there's a 60-minute timeout, so you might time out, but just go back into Streamlabs if you want to finish it. Yeah? Bill is my hero. Everybody give a round of applause. Bill, he made it where we don't have a timeout. Yes! Okay, so if you want to, complete your Streamlabs, but if you have time or you want to go ahead and do the now, there is a batch lab there. You're just going to go back out to the main display and say, I want to, instead of doing a Streamlab, I want to do a batch lab. Folks, please ask questions. We're going to keep doing this. Let's see, I ran a little long, so we're going to do this till about 3:45. Is that all right with y'all? Okay. And please use your lab time the way you feel is effective. As people begin their labs, I'll answer questions. Yes? Any questions? You get your socks, by the way. Still haven't forgotten. Yep. You're good?
We use Spring Batch today, but then is there any way for it to integrate with an external scheduler like control in?
So the way that the batch integrates with so like a scheduler is typically schedulers kick off batch jobs themselves, right? So what you're going to do is you're going to have those execute and launch that batch app itself. Batch does not actually, itself talk to the scheduler. It just writes data out. Now, what you can have you do if you want to have that batch app to send a signal to that, what you can look at is maybe pulling in Spring Cloud Stream, where Spring Cloud Stream can say, hey, on air, on complete, when the batch app, so batch have listeners. One of the things that Spring Cloud Task says is like, hey, do you want to emit a message to something through like a Rabbit or Kafka on like, on read fail or all the various listeners? It automatically integrates that and will emit a message out, and you can specify what message you want it to emit out.
You use the Spring Cloud Dataflow shell. So your scheduler launches Spring Cloud Dataflow shell. Or you have a call, because when you do that, the Dataflow starts with a control and it knows everything. If you don't, you will find out and you won't be able to restart it. Obviously, if you launch it via the shell, you also want to invest running the environment that Dataflow can deploy it. So if it's an environment where you can deploy it, you can use an external scheduler. But if you are running it on a dedicated machine, which a lot of people have, they've got a machine there, and there's a bar next to it, and if you touch the machine, that runs invite you. And that runs this very crucial batch job and that scheduler. What happens is, Dataflow can see that. If you make it a task, it's going to update task tables. Dataflow can look at the tables and report that. And that's all you get. You get the feedback. It does not control over that yet. Something that we're looking at, making a little agent that can live in that environment and do that for you, so that you don't have to drag that system, which might have all kinds of weird connections that prevent you from putting it inside of Kubernetes or wherever. So that's something that we're looking at, because we see a lot of people in that situation. And I don't want anybody to have to learn Kubernetes if they don't have to. I had to, and I'm still injured. But, so there's various options. So you need to decide, and we try to, so we can make visible what's happening, but we can't act on it unless we're in control.
That's also still enough for us, because we can signal that scheduler fast, it starts with job, but it should wait for a signal to come back as well.
Okay, so look, most of these will launch, and it will say it's locked. So what you would need is you would need to have something that runs because what happens with Dataflow, so your time was unable to launch. But after that, you're tracking the status, because that application is running, and then you act on that. So what you need is just something around that shell. What you can also do is the Dataflow client is actually a separate job.
You can embed it into your own app. And you can make it do all that. I'll look it up and see how we talk to run apps to see the program. Now, there's another article that awaitability. So you can launch this and wait for this to happen. And it'll chug along and wait for that to happen. It'll periodically check the page, and if it's finished, then it gives the right execute. So now you give the feedback to the sort of scheduler, but that it knows before.
You have end up with in jobs if you are creating on some of conditions from the people. You have to basically trigger based on the keyword conditions.
You spoke about composed clause runner. The composed clause runner will now take you a lot like this in the inside of one batch job in the steps. Composed clause runner brings that into better place. Now you can in jobs. One conditions are the way. You want decision making. You want decision making. You need to build that into yourself. Either that or something that drives something where you just was looking at the comparison. Is enough of that drives something. And if you want to update platforms do that themselves.
Yeah, probably
if you go to the platform and just say,
we do use some of the same
kill the point, then I will
not
know
to use that
point.
but what I'll do is
If I
use
destroy it, I can destroy it. At the moment, if you don't kill it, one, say it's a toy, because
yeah, keep the URL. Yeah, and
now
provide the URL with this.
what we want to do
What I'm going to do is I'm going to
allows
copy
you to do the own
Spring Academy is a fair general inbox.
mechanism.
Against here, looking at that.
What's one mechanism that would do that use the context? Actually want to build something. It's found. So then you start with context. Plug in model result. So the thing that's making the decisions about how it happens is this engine that I didn't build, but I thought that it was all the rest. And whether those things are the functions that you embed in place. And that way you can move forward, but the top layer stays the same. So at least that part of that orchestration, you can now sort of get like into sitting in between. Like so these ideas that I have will make it easier. So you can
This is like
the moment you got this control, you know what happened. From what you explained, how to figure out how to speed up we're trying to so if you just go and look at the all the monitoring stuff that we from it now, it's good in the bars of the but that means custom stuff.
yeah, give me mine. The Spring Academy. Yeah, give me
Whatever engine you're using,
like what kind of skills like this.
looking at right, so there's
But go ahead. So that's
my comment is
B. You know, it's like
in class. So just in case Which job it goes in.
Yeah, normally what we do is, yeah, we have to make some site, get a screen. That's we all, we typically, get that here. Okay.
So you know what's going to be.
Yeah, sure. Yeah, I mean, it's not even first. Yeah. 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 Shot. See if we can find a support project. VMware education.
Those services, they come back more than they trigger the jump. That's what
Well, yeah, here's the
city.
I'm the official maintainer.
It's something more.
The answer is maybe longer today they say, go ahead, what's that?
Now, it's a great academy, on demand, server data. Again, it's I'll do that means free academy. Go to the yeah. Yeah, so yeah, it's speaker. This is a now, did you see here?
Something against you and holding out the all it does is if another task somebody
see this now. It's we're all under VMware, but it's a wide but the certification is the same thing. And you'll see here, this is the same thing. Yeah, and that's you can take this and get one to would say though that you don't want to pay the money. Like this was spring classes that are able to say yes, you'll be and it's about the actual yeah, that's so you sign up to get that.
so because we're confident in our something like that.
It tracks. It says, I'm not familiar with VMware Marine theory. It looks like they're using third-party companies. So this sort of thing, I mean, it's kind of they're being, I just want to look at yeah, good class, actually, go back and look at it's like, you should have established this, whether you this is kind of your CMG thing, this is what I'm gonna send back.
But I dare you, like you said, it's not in front of his chest. The fun is what I sit on there. And then look all day long. Yes. Exactly. Same pace, yes.
Yeah, it might be 50 hours.
So one small. The prospect is this one. Just like that. You got to keep this. You want to learn a lot. You want to be an expert. So, you have to
yeah, okay. There's stuff from yeah.
So,
yeah, somebody does really back to that.
could do that. Because this is all like everything. You can have them all.
Yeah, this is important. Yeah.
Jerry, I ain't working now, gas company. Oh, yes. Got it. Yes, I know what that is. I know what company. That's a for, yes. Yes, so I cannot.
Yeah,
Yes, if I made a steam. Exactly. Well, but you're talking about it, so. Oh, it's from the schools, yeah. You should be reminded, you should be also too, so. So, most. With that, there's a real couple of things. Next step, where these we got now, I do some lots. And you have this problem. So let's talk about this. So I put the frame, get Dave, I don't know if it's not straight up, fantastic. And then I flat what spring to thought it is that flat is that top is what we need to write. It's you are getting data from there. Just exactly, but the we can run through this easier at that moment. It may not, I don't want to be talking about using stuff. It's going to be something that one day, that how about, I'm going to go ahead and put so we have a piece of for like and what if they want to add so that's so I know somebody's so I appreciate not even talking that so it's like I said you know, so then when you want to go
I'm going to do one quick announcement, and we'll be back.
You want to go around once more?
I can. I got to get my cardio in. All right, so I'm going to.
Oh, my watch has been congratulating me every day. Friday morning is going to be so disappointed.
Okay, so you want to put the lab in?
Yes, I'm going to.
Hey, folks, I'm going to, can we put this one? Hey, folks, I'm going to ask you to take a quick pause, real quick. Now, as Corneil is setting up his machine to finish out the laptop, he's going to talk a little bit more about installation, so you kind of get a feel for it. Once he's finished that, he's actually going to go back into labs one more time. But I have a favor to ask. So I'm going to open up 3 slots of my time, and it's cheap time, really. It's not like it's valuable. But what I would like for y'all to do is the following. If you think it would be useful to come to talk to me for about a half an hour, I'm going to have 2 slots on Wednesday and 1 on Thursday because it's about a half day on Thursday. And you're like, I just want to write napkin out what we're seeing, what we're doing at where I'm at. And if you would like to share that with me, we see how maybe data flow, how stream, how task, or what other the Spring project that we have that may help you out. At the end of their session, and we're supposed to end about 4:30ish or so, we'll try to see if we squeeze out just a little bit more time after that so you can have a chance to finish your lab. Come see me, and then we'll schedule a time where we can actually maybe do that white napkin talk. And I may invite a friend or two to kind of join us and see, we want to hear what you're doing, but also how we can help. Okay, so if you think that would be valuable, come see me afterward. Remember, we'll schedule a time and find a place over here somewhere we can meet. And I guarantee you 2 things. 1, I will learn, and 2, I will be caffeinated. So, folks, I'm going to turn it over to Corneil. Thank you so much.
Can you all hear me well? Thanks very much, Glenn. You're in the long run, the wrong line of business. I'm getting the end of the time of day when my auto completion stops working. So what I want to talk about quickly is installing data flow, because you would all, well, how do I do this? This must be a beast to deploy. Now, we've been working very hard to make that easy. And what I'm going to show you is how much work it is to get it running locally in Kubernetes, not plain command line apps, so that you have the Kubernetes experience, but locally. And then I'm going to talk to you a bit about some of the tools we're using to deploy it into production. There's a package manager called Carvel. So you probably ask, but why aren't you using Helm? Now, we have a team. So VMware is a huge organization. They acquired Bitnami, and Bitnami has a team that are creating Helm charts for everything out there. And the Bitnami team has a Helm chart for data flow. Carvel is incredibly powerful, and it has recently, in my view, at least matched Helm in functionality, and it's rising past. So it, in my view, is in the long term, is going to be a more powerful way to package and deploy data flow. And that's why we are sticking with it. So at the moment, we have a Corval deployment, and I'll give you the brief overview. But what I want to talk to you about is a plain vanilla Kubernetes deployment. So you can run locally by using Minikube or Kind. I've got some requests for, well, why don't you support the Kubernetes that's inside of Docker Desktop? I'll go and beg for a Docker Desktop license so that I can test and develop that piece of scripting. But it's literally this easy. We need to run a script that allow us to decide what we want to do. So we have a script that says, I'm using Minikube with Docker, or I'm using Minikube with VirtualBox, or Minikube with VMware. So what it means is when you're using Minikube with Docker, it downloads a Docker image that has the whole of all the Kubernetes stuff inside, and it launches that image as one process. Now, if you think about it, well, that sounds a lot more like a VM than a container. So that's why you'll see all these VM options are there. If you're on Windows, you can say, I want to use Hyper-V, because if you run Minikube with Hyper-V, then you're pretty bare metal Kubernetes. So there's various options. And it's called HyperKit on Mac. So what you need to do is you need to run a script, and you tell it which broker and database that you want to use. And I'm going to, no, this is not the one I want to show you. Yes, I am in the very incorrect resolution here. I'm actually going to drop it down to yes. So what we've started with the release candidate that's out now is we create a zip package, and it has a collection of files that you can download and unzip. And you can then run these scripts to do the local deployment. You don't have to clone the repo and do it from there. But those scripts allow you to set up. Is it big enough, or should I increase it more? Okay, I'm going to, you see, all the Mac users say, why don't you zoom in? And I'm like, there's one reason I'll get a Mac is for the zooming. Let me just do this and do that. Okay. So if you don't know the bash for one of these shells, when you say source, what you're saying is the script I'm running is actually running in the context of where I am. So I'm sourcing that script, I'm bringing it in, which is going to mean if that script says, here's a new environmental variable, then it will be in that environment. So I want this script to populate the environment with environmental variables that define the broker and the type of Minikube driver and the type of database I'm using and anything else. So I'm going to say use mk.sh. The first parameter is the type. I'm saying Docker. And then I'm saying I want to launch Rabbit. Thank you. I want to use MariaDB. And I'm going to skip the registrations of applications just to save some time. Because what I do is there's a script that actually, before you run this, you need to have especially when it comes to the data flow server and the skipper container and the compose task runner container, you need to have them on your machine. Otherwise, who knows where they're going to come from, and is it the right version that you're running? So my view is that I want you to make that decision up front. So there's there's a folder called images, and there's scripts in there called pull data flow, pull skipper, and it will pull the versions that you've set up. And then you know I'm using this version. And what we actually do is we load it into Minikube before we launch. So we know exactly what version Minikube is looking at. So what I've set up now is skip registration, and I'm running data flow and Rabbit. Let me see if I can disable notifications so that don't interrupt. Do not disturb. Thank you. So now I've set that up. Now, let me just see. I'm going to make sure destroy. So I'm deleting any previous Minikube cluster. So I've got no cluster running locally. Now I'm going to say configure Kubernetes. So it's now actually checking if I've got the latest image of Kubernetes, and it's creating a container. My machine has 32 gigs of memory. I've assigned 12 gigs to the cluster and 8 CPUs. And with that, I can do plenty. Okay. So there you can see it took 26 seconds to get a Minikube up and running. And now is the difficult part. We say install Dataflow. And now you will see that it starts launching something called BusyBox. It's a small container that you can use to create scripts, because BusyBox has got a collection of common utilities. And if you want to add things to your deployment, it'll launch it. So there's some things that use that. We've specifically chosen MariaDB 10.6. It's loading it. It will actually check. So if the version that you've pulled is already in Minikube, it's not going to push it. So it does check, and then it will skip it. So if after this, I delete the installation and I run it again, you will see that it won't need to upload those images again because they have been uploaded. So, and now I'm uploading Rabbit. And if you're using Rabbit Mcube, and you add the dash management, then you get a container that has the management console configured. And the standard port on Rabbit is 5672. And the standard port for the management is 15672. So now you take that port and you expose it to the outside world, and you've got your Rabbit console. Because when you're developing, you want to see in there. Chris?
What about K9s? Can I use it here to see?
Oh, yes, I'm going to show you now. How else am I going to show you there's a running cluster? So now you can see we're busy uploading the various data flow components. I'll start with the least important, compose task runner, and then I go to skipper and then to data flow server. And no, to be honest, I've come to love CTR. It is a stroke of genius insight to make things work. And you'll see once it's done, uploaded this one, it then creates the Kubernetes resources. So you can go look at the files. There's a few simple resources that created a system account. It creates a data source secret. So we show you how to use secrets so that you don't put a password in your YAML file. It's deployed Dataflow Server and Skipper. It's created various roles, and it's waiting for Kubernetes to say that the rollout of Skipper is complete. So now, what I forgot to do before I started the install is it actually told me you need to open a separate shell and run Minikube tunnel. So Minikube tunnel will launch an app with root privileges that can forward the ports. Okay, so I'm going to launch it, and let's see if my fingerprint makes the scanner happy. No, this only works in my home. There we are. Okay, so it's now running, and let me just close this and start it again. Now you see, where are my pods? Okay, let me just change the resolution a bit here. Where did displays go? There we are. I'm just gonna go to HD. I want to show you. So you will see at the top, it says all. And then it says SCDF, and then it says default. And next to pods, it says default. So we're looking at the default namespace. And I've learned the hard way, you don't use the default namespace for anything. If you're doing work, you do in a separate namespace. Because if you break the default namespace, then you have to destroy the cluster and start again. Unless you know a guy like Bill who can wangle it, okay? But, so I now type 1 and I'll see the SCDF namespace. And these are familiar, you've seen them before. So those are the same instances. Now I can quickly go to Dataflow Server, Shift F, and I'm forwarding the port, and I say OK. And now I can go to localhost port 9393, and I'm up and running. Or, and you'll see at the bottom here, it says you can source that whole thing, export Dataflow IP, and it will actually ask Kubernetes, what is the external port that you made available via the standard load balancer, and you can export that, because usually that's the kind of thing you want to have to do, is if you talk to something you don't know about. You want to get that address, and once you have the Dataflow address, you can give it to the shell, or you can use it with the REST API to make it obey your commands. So just to prove this to you, I'm going to source Kate's export Dataflow IP, and it now reports something over here, and I'm launching that, and ooh, what is that? The home page is actually Atios response with all the resources, and /dashboard is the one that you've been visiting to get this experience. So as you can see, the whole thing took about less than a minute to get a cluster up, and probably a minute or two to deploy the first time. If I go and I now run delete SCDF, what does it do? It takes that SCDF namespace and it tears down all the resources, and then you can do an install again and you get a clean install. And during that install, it checks if there's newer versions of the stuff. So for me, that's ideal for a local testing environment, and you have a real case. Because how does this process work? You start by developing that function and you put it inside of a unit testing environment. Yes, this function does the work. I now need to package it as an application, which means I need to add various dependencies, and I need to set a few properties to have the bare minimum to make it work. If it's stream, then you need to tell it about the function that needs to be bound to the stream, and that same function, how to bind it to input and output, or just input or just output. And then Dataflow adds the rest, because Dataflow says output's bound to this and input is bound to that. And then you want to know this thing actually works, because you don't want to take this and, oh, the function works and now we deploy it to production, because something can go wrong. Because you could have made a mistake and then one of the bindings doesn't work as expected. So you can fire this up and you can run tests against it. We actually have, I must see if that's on one of the OSS repos. I think OSS CI has a piece that uses GitHub Action to start up a local Minikube cluster, deploy the created containers, and runs integration tests against them. Because that's the kind of thing you want to do in the real world if you're going to deploy to K8s. Otherwise, you will get surprises every now and then. So let me quickly talk to you. How much time have we got left? We've got 20 minutes. I'm not going to use all of it. But Chris.
Tell them where to get these. On the release notes of Dataflow, there's an
Yes.
attachment that you mentioned. So if you go to github.com and go to Dataflow repo and release notes, you can see a zip of all the scripts that Corneil is just using. So if you want to continue playing around with Dataflow, which is easy way to yourself.
I'm actually going to GitHub, are you crazy? It's me. I've been there every day. Okay, that was not the right account. This is the right one. So what we've done is there's our release candidate tab, and you'll see right at the bottom there's a download. And that contains all these scripts, but they're also inside of the Dataflow repo. So there's a package in the repo that's obviously named Spring Cloud Dataflow package. And it's a Maven assembly that pulls everything together and creates the zip file and publishes it. So take it for a spin. If you run into a problem, it was my fault. So what I want to do is I quickly want to talk about this. So I mentioned Corneil. The similarities with Helm is overwhelming. You have a URL that defines a package, and we have some examples and documentation that says that to deploy that package, you want to use a values file. So values file is a YAML file with properties that tell the package what to do. So that package can deploy Dataflow. It can set the properties on Dataflow on whether it's supporting streams, tasks, batch tasks, and scheduled tasks, or you can turn those off. They're usually on by default, but you can turn them off. So if you know you're not doing any streams work, then you can disable streams. If you're not doing any task work, you can disable that. So it simplifies the UI. But you are going to use that values file to tell it about where to find the database, because you are not going to use that single node container to run production database. Because I will not take the blame for that. I'm telling you now, please don't do that. Use a Kubernetes operator or a managed database service somewhere. But you need to tell Dataflow how to find that. Those entries go into the value file. You need to tell it where to find Kafka or where to find Rabbit, because you don't want to use that single container Rabbit to run production. You want to use a managed service or an operator. So you set those up, and then you install the package into the cluster, and then you deploy it. And then it will do the work to make sure everything is fine and tell you if there's a problem. And you will see there's some extra controllers running alongside your normal stuff, but they're in different namespaces. So when you look at the Dataflow namespace, it doesn't look any different. There's just other stuff in the back. And you can update that values file and roll it out and apply changes, and off you go. So,
All right, I've got one message before you close. I've got one more thing I need to say.
Please.
All right. Well, folks, thank y'all for coming. And so we got about 15 more minutes. Please work on your labs. I want to do a special shout out real quick. We ran our entire environment today on Spring Academy. And since you registered, you have access to the free courses that are out there. Mahmoud bin Hassin, who's the Spring Batch lead, just finished the Spring Batch course. So if you're interested in learning more about Spring Batch, it's a primer. So if you're already used to, if you already coded it, you're okay. But if you've never coded it before, it goes through the entire process. And like what we saw in our own classroom, it will actually give you all the resources, a VS Code, a terminal, so you can actually go in and play with the very code that he's training you how to do. It's free, kick the tires on it. And again, I want to thank Spring Academy for hosting us today for this talk. Now, to close out, please finish your labs. We have room for about another 15 minutes. Have questions, feel free to ask us. And also remember, if you would like to and you want to take advantage of the white napkin conversation, just come see me and we'll schedule a time for tomorrow, or Thursday, see what time works for us both, okay? Folks, thank you for coming. We appreciate it so much. I appreciate y'all. Thanks.
I want to give a shout out to this guy. He is a force of nature. He's worked so hard on this thing. He's just dragged Chris and us along. If it wasn't improper, I would have shown you the marks on my knee. But it's been an incredible ride. And I'm glad to be here and share this with you. And please, if you have any feedback, reach out. You'll see on GitHub, there's not just issues, there's a discussion tab. We're monitoring Slack Overflow as well. Well, I must say, we've been not as good on Slack the last 3 weeks, on Stack Overflow the last 3 weeks as we should have been. But we try to keep in touch with the community. And there is a professional version of Dataflow that you get when you, if you sign up for Spring Runtime, which basically means you have support for Spring, you will get Spring Cloud Dataflow support, and you'll get access to the Pro version. It has a few more features. And if you log a bug, it'll make us jump higher because that bug is at the top of the list. And but the bulk of the functionality is the same. So it's not like you are missing out on stuff. But if you're in trouble, you get to the front of the queue. And I think after this week, you know the meaning of the front of the queue. So any questions? Share or put up your hand.
When we come
find the site? How do you get?
We are going to, yes, we are going to publish these. Okay. So we are going to publish these, and I think they've got a mechanism where they're going to make the links available. I can't tell you right now exactly where that's going to be, but I want to make sure that we get that info. You will not believe how difficult it is to communicate with you because you've signed up and you've given your
I'll tell you what.
access, but we're not allowed to see that information.
Well, I'll tell you what, here's what I'll do. I'll make it easy for you. Okay, I want you to write down 6 letters. And it's not a nasty word, I promise. So on my GitHub account, I'm going to post a PDF of the slides that we had here. And it'll be, yeah, okay. I know, Glenn, typing, really? I don't have a link yet. Okay, look up. Okay, it's going to be github.com/CPPWFS. C, like C++. I'm old. WFS.
I always wanted to know.
I will tell you at dinner tomorrow night. I promise.
Okay.
This is a story. Okay. CPPWFS. And then what you're going to see is you'll see S1. This is what I call S1 Lab, Spring 1 Lab.
Yes.
Okay. And I will host that there, and I'll put a PDF of the slides that we had here. Okay. And I will try to have that up. I can tell you, it will probably be Friday because I'm going to be at the airport and I'll have some time to do it. Up until then, I'm just going to be, well.
We're going to have to, we need to fight off Josh from inviting us.
No, yeah, okay, yeah, that's a whole different swear. Okay. Real quick, if you want to, please take a survey here. Let them know how we did, what we did, what we do better, all that good stuff. So if you want to take a picture of that. And lastly, okay, hold on. Chris, I linked up computer. You can use your finger magic here.
Finger reader works. Oh, it's
Yep.
open.
Okay, that did. All right, sweet. All right, so
He
We're
just
going-
came close enough.
yeah, that's it. He just had his.
It opens on my wall.
Yes.
Oh, it did? Okay. So in this case, what I want you to look at right here. Can you please also share your feedback of how you felt about how the labs work, your experience in using Academy, not necessarily the lab, but the Academy. How did it feel to actually go in and start a data flow or look at the data flow, use it to shells? You can put that information right here. You see where I'm highlighting this right here? Please put your feedback there. That's valuable because that will make Academy even that much better. So put your feedback there. By the way, my name is Brian Johnson. But if you could do that as well as also on the previous link. This is pretty much the same link as you had with the other stuff. We most appreciate it. Thank you, folks. Sorry about the rough start, but we got there.